Pre-AP Precalculus. This is homework section 10.4. We are focusing on some identities and difference identities for sine, cosine, and tangent. Problems 1 and 2, an angle theta is described. Draw and label the reference triangle for each angle, and then find the exact values of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Well, let's draw and label this reference triangle first. Number 1, we're told that cosine of theta is negative 5/13. Cosine is x over r. R is always positive, so this negative has to go with the top number. So x is negative 5 and r is 13. X could be negative in quadrants 2 or 3 because you're going to the left. This says that we are terminating in quadrant 3, so that means that our reference triangle is going to be down here in quadrant 3, making an angle like so. That angle's theta. As always, we have to know what x, y, and r are. We know x is negative 5. We know r is 13. To figure out what y is, use the Pythagorean theorem, or if you know your Pythagorean triples, this is a 5, 12, 13 right triangle, which makes y negative 12. Specifically, we know from this that sine of theta is going to be negative 12/13. Cosine of theta, which we were told at the beginning, is negative 5/13. And tangent of theta, which is y over x, is negative 12 over negative 5, which is 12/5. So all we've done so far is we've drawn and labeled the reference triangle. Now we need to find the exact values of sine of 2 theta. Hopefully you're writing small because there's not a lot of room here. Sine of 2 theta is equal to 2 sine of theta times cosine of theta. And I misspoke at the beginning of this homework. This is not sum of difference identities. This is the double angle identities for sine, cosine, and tangent. And we know from what we wrote up above that sine of theta is negative 12/13. Cosine of theta is negative 5/13. If we multiply the 2 and the negative 12 and the negative 5 together, we get 120. 13 times 13 is 169. That's what sine of 2 theta is. Now let's figure out what cosine of 2 theta is. There are several versions of the double angle identity for this. I'm going to use the cosine squared of theta minus sine squared of theta. That's the one that I typically like to use. We have above that cosine of theta is negative 5/13. That fraction's being squared. Sine squared of theta, sine of theta is negative 12/13. That's being squared. When you square a fraction, you square the top and you square the bottom. So we're going to get 25 1/69 minus 144 1/69. If we subtract those, we get negative 119 1/69. That's cosine of 2 theta. Third part of this, figure out what tangent of 2 theta is. Tangent of 2 theta is equal to 2 times tangent of theta divided by 1 minus tangent squared of theta. We know that tangent of theta, according to what we have written up above, up in this area, that is 12/5. So we have 2 times 12/5. And we are dividing that by 1 minus 12/5 squared. 2 times 12/5 is 24/5. If I square 12/5, I'm going to get 144 over 25. And I can change this 1 to 25 over 25 if I want to get common denoms. It's going to give me 24/5 divided by, if I subtract 144 from 25, I'm going to get negative 119 25ths. It's a complex fraction. To fix this, I'm going to multiply the top and bottom by 25, which is equivalent to multiplying by 1 because 25 over 25 is the same as 1. These 25s cancel. Here 5 goes into 25 5 times. So I have 24 times 5, which is 120, and then negative 119 times 1, we'll say. And that gives me that tangent of 2 theta is 120 divided by negative 119. See if we answered all the questions. Draw, label, find each of those 3 things. So we're finished. Got all this work combined. Maybe it's smart to circle those answers. Part 2, question 2, I should say, is a similar question. This terminates in quadrant 4, so I'm going to draw my reference triangle in quadrant 4. Theta would be this angle. Or to do any of these problems, we have to know what x, y, and r are. Sine of theta is y over r. R is always positive, so it's 4. Y is negative in quadrant 3, so putting the negative with the 3 seems appropriate for many reasons. This is not a Pythagorean triple, so we have a little bit of work to do for this. X squared plus y squared is r squared. X in this case we don't know. Y is a negative 3 and r is 4. It's going to be x squared plus a 9er equals 16. X squared is 7. X is plus or minus the square root of 7. We are in quadrant 4. Therefore, it is a positive square root of 7. While I'm here, I might as well just jot down what sine of theta is, which I know is negative 3/4 told in the directions. Cosine of theta, that is x over y, pardon me, x over r, so square root of 7 over 4. And then tangent of theta is y over x. I'm going to rationalize this and get negative 3 square roots of 7 over 7. So let's try to figure out what sine of 2 theta is. According to the double angle identity, that is equivalent to 2 sine of theta cosine of theta. Sine of theta we're saying is negative 3/4. Cosine of theta we are saying is square root of 7 over 4. 2 times negative 3 is negative 6. Negative 6 times the square root of 7 is just that. 4 times 4 is 16. This is sine of 2 theta. Let's figure out cosine of 2 theta. That's going to be equivalent to cosine squared of theta minus sine squared of theta. Cosine squared of theta is going to be square root of 7 over 4, quantity squared. Sine squared of theta is negative 3/4 times quantity squared. Square root of 7 squared, 7. 4 squared is 16. Negative 3 squared is 9. 4 squared is 16. This is going to be negative 2/16, which is negative 1/8. Cosine of 2 theta, negative 1/8. Negative 1/8. Next we have tangent of 2 theta, which is 2 times tangent of theta divided by 1 minus of tangent squared of theta. Tangent of theta, we have written down, is 3, you know what? I'm actually going to use this version of it. Might be easier to simplify, we'll see. Negative 3 over the square root of 7. Let's see what happens. over 1 minus negative 3 over the square root of 7 squared. Multiplying in my numerator, it's going to be a negative 6 over the square root of 7. In my denominator, if I square the negative 3 over square root of 7, I'm going to get 9/7. I'm going to change the 1 to 7/7. It's going to make this negative 6/7 over negative 2/7. And I'm sorry, it's not negative 6/7. It's negative 6 divided by the square root of 7. I'm going to multiply by 1 in the form of negative 7 over 2, negative 7 over 2. What that does for me at my denominators, the 7's cancel, the 2's cancel, the negatives cancel. And then I'm going to have negative 42 7 square, hold on a second, I can do some more canceling here. I can divide both 2 and 6 by 2, and that makes this a negative 3. So negative 3 times negative 7 is 21 over the square root of 7. If we wanted to rationalize our denominator, we could make this 21 square roots of 7 over 7, which makes this 3 square roots of 7. So tangent of 2 theta is 3 square roots of 7. Probably okay to leave it this way as well, although that's a little bit lowbrow. Moving on. Probably should also circle my answer. Number 3, verify the equation below is a trig identity. So let's do this. Let's get a little cray-cray, shall we? I like to work with the more complicated side first. So I'm going to do that. I'm going to change sine of 2 theta into the double angle identity 2 sine of theta cosine of theta. In my denominator, I'm going to change cosine of 2 theta into cosine squared of theta minus sine squared of theta. Now when you do this, you need these parentheses because you are subtracting whatever's inside of there. That's going to make this 2 sine of theta cosine of theta over 1 minus cosine squared of theta plus sine squared of theta. You probably recognize what this is. That's sine squared of theta. So I could make this 2 sine of theta over cosine of theta divided by sine squared of theta plus sine squared of theta. And if I combine those on the bottom, I'm going to get 2 sine of theta cosine of theta over 2 sine squared of theta. Now at this point, using some algebra, I can see that 2 divided by 2 cancels, sine divided by sine squared cancels, and I'm left with cosine of theta over sine of theta, which the right side has been all along in the form of cotangent of theta. Cool. Number 4. Interesting. Should I work with the left or the right here? The left side is pretty complicated. Right side is also pretty complicated. I'm going to do a little bit with the right first, just to show you what in the world is this cosecant of 2 theta business, because we don't have that double angle identity. What we do have, though, is that this is the reciprocal of sine of 2 theta. And that's going to be equivalent to 2 over 2 sine of theta cosine of theta. 2's cancel, and you get 1 over sine of theta cosine of theta. I'm going to chill there on the right side. I could make that cosecant of theta times secant of theta, but I'm going to go to the left because the left's pretty complicated and try to make it more simple. I'm going to change cotangent to cosine of theta over sine of theta. I'm going to change tangent to sine of theta over cosine of theta. Get common denominators. I'm going to multiply the top and bottom of this first fraction by cosine. That's equivalent to multiplying by 1. Top and bottom of this one by sine of theta. That's equivalent of multiplying by 1. That's going to give me cosine squared of theta plus sine squared of theta over sine of theta cosine of theta. Cosine squared of theta plus sine squared of theta is 1, of course, and that gives us the left and right sides being identical. Dunsies. Number 5. We have cosine of 4 theta. That seems to be a little crazy. I don't know how to work with cosine of 4 theta, but I do know how to work with cosine of 2 theta plus 2 theta. Agreed? That is going to be equivalent to cosine of 2 theta times cosine of 2 theta minus sine of 2 theta times sine of 2 theta. That's the difference identity for cosine. Now what can we do? Well, I know what this is. That is cosine squared of theta minus sine squared of theta. That's a doubling of identity from this section. And this is the same, so this is just going to get repeated. And then over here on the right, I think I see something that I probably should have done. Wait for it. Wait for it. No, I'll just keep going. Then I'm going to subtract from that sine of 2 theta. That's a double angle identity. That's going to be 2 sine of theta cosine of theta. I'm going to have another one of those because there's another one here. 2 sine of theta cosine of theta. What can be done now? Here's what I'm trying to accomplish. The right side only uses cosines, and this left side has sines and cosines. So if I can try to make this less siney and more cosine, that's probably going to be a good idea. So here, for example, I can replace sine squared of theta with 1 minus cosine squared of theta. So I'm going to do that. So I have cosine squared of theta, subtract, I'm going to put in here for sine squared of theta 1 minus cosine squared of theta. I'm going to do that again for this one beside it because they're the same. And then here, I'm going to multiply this stuff out. Just multiplying a bunch of things together. I got a 2 squared, which is going to be 4. Sine times sine is sine squared. Cosine times cosine is cosine squared. I still don't know how this is going to work out. That's the truth, but I've got high hopes. Simplifying in each bracket, I'm going to have cosine squared of theta minus 1 plus cosine squared of theta. And this set of parentheses beside that is identical. Over here on the right, I still don't want sine squared in the problem because the right side doesn't have any sines in it. So I'm going to change the sine squared to 1 minus cosine squared of theta times the cosine squared of theta that was already there. This is just a monster, isn't it? This set of parentheses is going to become 2 cosine squared of theta minus 1. The next set of parentheses will become the same because they're identical. And then for this next one, if I distribute the cosine to this and the minus 4, I'm going to get minus 4 cosine squared of theta plus 4 cosine to the 4th of theta. There is a much easier way to do this problem that I don't know if you're ready for, but I should have done it that way. I regret not doing it that way. Multiplying this out, we're going to do the FOIL method, box method, distributive property, whatever you kids are calling it these days. Multiplying this, I get 4 cosine to the 4th of theta. Multiplying here, I get minus 2 cosine squared of theta. Multiplying here, I get minus 2 cosine squared of theta. Multiplying here, I get plus 1. These are the same term, but they are inverses of each other, yes? Oh, no, they're not. One squared and one isn't. So minus 4 cosine squared of theta plus 4 cosine to the 4th of theta. Let's see, what like terms do we have? Minus 2 cosine squared, minus 2 cosine squared, minus 4 cosine squared. That looks familiar. That's going to be a minus 8 cosine squared of theta. Bring this plus 1 down. If I put these two together, I get 8 cosine to the 4th of theta. This is all equal to what the right side was all along. So what's the better way to do this? I won't show you this now since I just did all this horrible work. But the much faster way to do this is to factor this. Factor that little fella down, and if you were to do that, I think that you would get this much faster. Number 6. Same instructions. The left side is more complicated, so I'm going to work with the left side. This is the difference identity for cosine, which is going to be cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle, divided by cosine of A times sine of B. Nothing cancels there. I don't have any idea what to do with the left side at this point. So I guess I'll work with the right side. Tangent of A is sine of A over cosine of A. Cotangent of B is cotangent of B over sine of B. To get common denominators, I'm going to multiply this fraction by 1 in the form of cosine of A over cosine of A, and this one times 1 in the form of sine of B over sine of B. That's going to give me sine of A times sine of B plus, I wrote cotangent here. It's supposed to be cosine. I don't know what I said. Hopefully I said it correctly. Plus cosine of A times cosine of B all over sine of B cosine of A. Now that's what the left side is, but it's not written identical. It must be written identical. So the commutative property says I can switch the order of those, be sine of B times cosine of A. Also says I can switch those around, so I'm going to get sine of A times sine of B plus cosine of A times cosine of B. Much better than the previous problem. Number 7. This looks very similar to the last one that we just did. So sine of A plus B is the sum identity for sine, which is sine of the first angle times cosine of the second angle plus sine of the second angle times cosine of the first angle all over cosine of A times cosine of B. Over here, tangent of A plus tangent of B, we could make sine of A over sine of B plus sine of B over, this first one's sine of A over cosine of A. Second one's sine of B over cosine of B. To get common denoms here, I'm going to multiply this fraction by cosine of A on the top and the bottom, same as multiplying by 1. Here times cosine of B on the top and the bottom. Same as multiplying by 1. And I'm working with the right side now because I don't know what to do with the left side. I honestly have nothing. I got nothing. So that's going to give me sine of A cosine of B plus sine of B cosine of A over cosine of A cosine of B. And that's what the left side is already. Cool. So it worked out. Lovely. Number 8. Sine of theta plus cosine of theta, quantity squared. Well, that's going to equal sine squared of theta. This is FOIL method, box method, distributive property, whatever kids are calling it these days once again. Plus 2 times sine of theta cosine of theta plus cosine squared of theta. Hopefully you recognize that if I were to group together sine squared of theta plus cosine squared of theta, that's the same as 1. And if I were to check out this as one entity, that's the same as 2 sine, that's the same as sine of 2 theta. Hey, that's what the right side was all along. Look at that. Christmas miracle. Let's keep trucking. Number 9. Let's see, we just got 4 more to do. Number 9, we got this fella. Left side looks more complicated to me, so I'm going to work with it. I'm going to change tangent to sine over cosine. Sine of 2 theta is the same as 2 sine of theta cosine of theta. It's a double angle identity. Cosines cancel. Let's give me 2 sine squared of theta. Don't know what else to do with that. I go to the right. I can GCF a 2 out of the right. 1 minus cosine squared of theta is sine squared of theta. Boom, same. 10. I will start with the left on this. Sine of 2 theta is 2 sine of theta cosine of theta. Sine of thetas cancel. So now we have 2 cosine of theta. You know what? We can move this to the top and make this 2 cosine of theta. That was easy. Done. Number 11. Oh, the right side, that's easy. That's 1. Wasn't the most complicated side, but that was pretty easy to pick out. On this other one, I could rewrite this as cosine of theta times sine of theta times 1 over cotangent of theta. Just rewrote the fraction. Cosine of theta times sine of theta is cotangent of theta. Multiplying 2 reciprocals, you get 1. Yay! Number 12. Well, we are booking. It's a good thing you got a pause button, am I right? I'm going to work with the right side and see what that does for me. No, I'm not. I'm going to work with the left side and see what that does for me. So this is the same as 1 over sine of theta. Cosecant of theta is reciprocal. Sine of 2 theta is 2 sine of theta cosine of theta. And secant of theta is the same as 1 over cosine of theta. Those cancel, and that gives me 2 cosine of theta. If I want common denominators, which I do, I'm going to multiply this by cosine of theta on the top and the bottom. So I can add these fractions. It's going to give me 2 cosine squared of theta minus 1 over cosine of theta. Now, if you know your identities well, 2 cosine squared of theta minus 1 is the same as cosine of 2 theta. If you don't realize that, you can get to that point by manipulating this a ton. But if you know that, then that makes that pretty quick and easy. Now, the right side has a cosine of 2 theta. So does the left. The left side has divided by cosine. The right has a secant. Well, I can change secant to the bottom of the fraction by putting its reciprocal down there. So now the left and rights are the same. All right, 13, the last one. Left side's definitely more complicated. 2 times tangent of b is going to be 2 times sine of b over cosine of b. The denominator, this is the double angle identity for sine, 2 sine of b cosine of b. To make this not complex, I'm going to multiply by 1 in the form of cosine of b over cosine of b. Those little fellas cancel. That's going to give me 2 sine of b over 2 sine of b cosine squared of b. Hey, the sine of b's cancel. Hey, the 2's cancel. Now I have 1 over cosine squared of b, which I think you know is secant squared of b, which the right side has been all along. Boom, done, roasted.